Okay, Wildcats, today we're looking at Thursday, October 18th, linear programming on page 23. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Linear programming, page 23. Linear programming steps. Step 1, define the variables. Step 2, write the constraints. Step 3, sketch the feasible region. Step 4, identify the vertices. All right, you may have to solve a system to identify some of the vertices. Step 5, write the objective. Step 6, use the vertices and the objective to find the maximum and minimum value. Step 7, state the conclusion in sentence form. All right. Now, go ahead, finish up your notes. Now your notes are finished. Let's take a look at examples on page 23. Now, as you notice, I had to fix the lines on the graph. I did that before the video, save you some time in the video. This line right here, I think you had to add, and like one of these lines you had to add. So you might take some time to fix your graph so it's easier to see. All right, example 1. Good Life Bakery Cafe bakes 2 breads, A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. One batch of A yields a profit of $40. One batch of B yields a profit of $30. How many batches of each bread and bakery should bake in order to maximize profit? Now, as we go through this video, just so you know, this is the most difficult concept I'm ever going to teach you this year. So at any point in the video, if you get stuck and you get frustrated and you don't understand, stop, wait to class, and I'll work these problems again in the teacher-led station. Okay? All right. So the first thing I'm going to go over, I'm going to use some different colors. I'm going to use a purple, a light purple, a green, and a red. Okay? You're going to need 4 colors. Okay? If you try to do this in pencil with no color, it gets way even more confusing. All right, the first thing we're going to define the variables. So A is the number of batch A. B is the number of batch B. Now, you can't have negative batches. So A has to be greater than or equal to 0, and B has to be greater than or equal to 0. Okay? So with that, here's A, here's B. Notice we're in the quadrant where it's positive, positive because of this A. Okay. Now let's go and make our scale. Let's go by tens to 100, and let's go to 10 to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 is right there. Okay. All right. So the next thing is we have to look at batch A. Okay, batch A. Now batch A uses 5 pounds of oats, and batch B uses 2 pounds of oats, which the company says it has 180 pounds of oats. Okay, so we know that 5A plus 2B has to be less than or equal to 180. Now we say in batch A we have 3 pounds of flour, and in batch B we have 3 pounds of flour, and then it says there's 135 pounds of flour available. So that's 3A plus 3B is less than or equal to 135 pounds. Okay, now we've defined the variables. Okay, check. We've written the constraints. Check. Now we need to sketch a feasible region. So to do that, we need to graph this. Okay, so to graph this one, we know that A is equal to 180 divided by 5, which is equal to 36, and B equals, and I'm going to use the color A, equals, B equals. Now, this is kind of in the x, ax plus by equals c format, okay? So then that's 180 divided by 2 equals 90. So this point is 36, 0, and this point is 0, 90. So let's go ahead and graph those, okay? So 36, 0. So 10, 20, 30, 36 is right here because it's between 10, 20, 30, 40, so it's between there. And then 90 is 10, 20, 30, 40, 50, 60, 70, 80, 90. That's 36. So we have our 2 points on the line. Okay, now we have A, in this case, A equals 135 divided by 3, which is 45. So your point is 45, 0. And then B equals 135 divided by 3, which is 45 again, but that's 0, 45. So 10, 20, 30, let's see, 10, 20, 30, 40, 50. So 45 is right there. And then 10, 20, 30, 40, 50. So 45 is right here. Now we have our sketch of our graph. A lot going on in this graph. Okay. Now, almost forgot. This is less than, so we shade below. Okay. And then this also is less than, so we shade below. And this is our overlapping region. Okay. So now we sketch the feasible region. Now we need to identify the vertices. So to do that, we're probably going to, what are we going to do? Guess we're going to have to do it right here. Have to write some more. All right. Now, to identify the vertices, we're going to have to solve this. So what we need to do is multiply this equation by 3 and this equation by -5. Okay? So this is defining the vertices. Okay? So that's 15a plus 6b. And we're just going to go to equal because we just need to find a and b equals 540. Now, -3 times that's negative 9a minus 9b equals negative 675. So that, wait a second. That's not right. I multiply by 3, -5. -3 times 3 is negative 15a. -5 times 3 is a negative 15b. I don't know where I get those numbers from. And then this is correct, negative 675. So I should have multiplied by -5. I accidentally multiplied by 3. So then the a's cancel, then you get negative 9b equals negative 135. Divide both sides by -9. B equals 15. Okay. And then now we need to solve for A. So we can go back to this equation, plug 15 in for B. So that's 5A plus 2 times 15 equals 180. Let's see that. Equals 180. So then that's 5A plus 2 times 15 is 30 equals 180. Subtract 30 from both sides. So 5A equals 150. So A equals 30. All right. So the vertices then is 10, 20, 30, 10, 15. So this point right here is your vertices right here. There's one vertices. That's the point 30, 15. Then we have this vertices. We already have. This vertices we already have. And then this vertices. So these are your 4 vertices. So your vertices are starting here, 0, 0. See, 0, 45. See, then going to here, 30, 15. And 36, 0. Okay. All right. So now we've identified the vertices, okay, which we did have to solve. Now we need to write the objective, okay? So the objective is, now that has to do with the money, okay? The 40 and the 30. So 40A, because it's $40 for the flour, and then plus 30B, and we're looking for the max. See, a lot of information, a little bit of space, okay? So because it says maximize profit. Okay. Okay, so we know our first vertices is 0, 0. So that would be 40 times 0 plus 30 times 0. So that's a 0 profit. So now we try the next vertices. 0, 45. So that's 40 times 0 plus 30 times 45, and that equals 1350. Now the next one is 3015. So it's 40 times 30 plus 30 times 15, and that equals 1650. And then the last one is 360. So it's 40 times 36 plus 30 times 0 is 1440. All right, so now, okay, it says maximize, so we can see here that this was our maximum value. So now we conclude. All right, so you can say the bakery should bake 30 batches of A and 15 batches of B to maximize the profit of $1,650. All right. Wow, that was intense. All right. So now let's take a look at, I'll give you a few seconds to finish up and look over that. All right. So now let's take a look at example 2. All right. The TSS librarian is purchasing new bookcases. The store needs 320 feet of shelf space. Bookcase A provides 32 feet of shelf space and costs $200. Bookcase B provides 16 feet of shelf space and costs $125. Because of space restrictions, the store has room for at most 8 bookcases A and 12 bookcases B. How many of each type of bookcase should the librarian purchase to minimize the cost? All right, so let's come back to this. So the first thing we do is define the variable, okay? So A is the number of bookcase A. B is the number of bookcase B. All right, so now we know that we have A provides 32 feet of book space and B provides 16 feet of bookcase, and there's a total of, let's see, where's that? 320 feet of shelf. So we know that that's 32A plus 16B could be greater than or equal to 32 feet. Okay, because it doesn't say it has to have at most. Okay. Now the next part says that it has to have at most 8 of bookcase A. So that means A has to be less than or equal to 8. And it says that at most 12 of bookcase B. So that means B has to be less than or equal to 12. So again, this is A, this is B. Now in this case, let's make the scale by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, I forgot to tell you, but you want to fix up your lines so it's easier to use. And then let's count by 2 here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so let's first look at the A and B restrictions. Okay, so A has to be less than 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8. So has to be less than 8 there. Okay. And then B has to be less than 12. So 2, 4, 6, 2, 4, 6, 8, 10, 12. So this would be 12. And so here you can start to see the overlapping region. Okay. Now we need to graph this line right here. Okay, so to graph that, come over here. So remember, this is in the form of AX plus BY equals C. So A equals 320 divided by 32. So that equals 10. So that point is 10 comma 0. And then B equals 320 divided by 16 is 20. So then that point is 0, 20. So we connect all on. Now, this says greater than, so it has to be this region. So this is the overlapping region. Now, technically, it's greater than here too as well, but that's your overlapping region. Okay. All right. So we've defined the variables, we've written the constraints, we sketched the feasible reason. Now we need to identify the vertices. Now this one's easy because your vertices are right here, here, and here. So your vertices are 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 4, 6. Oh, whoa, I'm sorry. I forgot these are counted by twos. So 1, 2, 3, 4, 2, 4, 6, 8, 10, 12. That's 12. Okay, now this point is 8, 2, 4, so 8, 4. And then this point is 8, 2, 4, 6, 8, 10, 12. So 8, 12. Okay, so now we've identified the vertices. Now we need to write the objective. All right, so the objective has to do with the $200 and the $125. So there's $200 for bookcase A plus $125 is put aside for bookcase B. In this case, we want to find the minimum because it says minimize right there. Okay. Oh, lock the camera there. All right. So there's our objective. You can tell this problem is lots of fun, but very scary fun, very difficult. Okay. And we need to make room for 3 vertices. So let me draw lines for 3 vertices. That should be good. All right. So the first one is 412. So that would be 200 times 4 plus 125 times 12, and that equals 2,300. Then our next vertices is 812. It's 200 times 8 plus 125 times 12, and that is 3,100. Now our last vertices is, well, I guess I switched orders. So I did that one, now I'll do 8, 4. So that's 200 times 8 plus 125 times 4 equals 2,100. So we have our minimum right here. Okay, so the last thing is we need to state our conclusion. And I think I might need to take some space here. For that conclusion. So what we'd say is the librarian should purchase eight of bookcase A and 4 of bookcase B to minimize the cost of $2,100. All right, so wow, that was crazy difficult, crazy scary. If you understood it though, you're amazing. So start working on the examples. And I assume that if it was difficult, you didn't get to this point. But if you did and it was still difficult, write it down. Just know, come to class and I'll go over this again with you in the teacher-led station. Okay, so with that, have a wonderful Wildcat day.